All right, so we talked about meiosis and how you get sperm and eggs. Now we're going to talk about how do you tell the different sexes genetically, right? So there are sex differences in the chromosomes. It depends on the organism on how that difference shows up. So let's talk humans first. So how is sex determined in humans? So I'm talking biological, genetic sex. So which parent determines the sex of their baby? So we're going to focus on this question. Which parent determines the sex of their baby and why? Okay, so the parent that determines the sex of the baby is the male. Okay, and that has to do with the chromosomes. So there are two sex chromosomes for humans. They are the X and the Y, and the X chromosome is the big one. They don't normally have color. They colorized them for this picture. I'm not sure exactly why they colored them this way, but you can see the X chromosome is much larger than the Y chromosome. The Y chromosome is not named Y because it looks like a Y. It actually is an X. It's just that these legs are really short. So in this picture, it looks a little bit like a Y, but it does have the centromere here in the middle with two little legs down here at the bottom. You might guess that there are a lot more genes on the X chromosome than the Y chromosome. In fact, we know that you cannot survive without an X chromosome. No one has been born without an X chromosome. You can, however, and we'll talk about this later, you can be born with just an X chromosome and just a single X chromosome. You don't need two X chromosomes. You can be born, without a Y, but you must have at least one X chromosome. So there are important genes on here that you must have in order to survive. So how do the sex determination work as far as genetics go? So XX for female. So two X chromosomes for female. We'll talk about that there are some variation or some different ways that that can occur when the division for chromosomes go wrong. But that's the normal version. And then XY for males. When meiosis occurs, all of the eggs normally get one X chromosome for females. So the female is only going to give an X chromosome. So mom does not determine, the female does not determine the sex in humans because there's only an X chromosome to pass on. The male does determine it because it's 50-50. Half the sperm are going to get an X, half the sperm are going to get the Y, because during meiosis 1, the X is going to go into one side, the Y is going to go into the other, and then these will each get divided into these two. This will get divided into these two, okay? So this is why if you've heard there's a 50-50 chance of you getting a boy or a girl, this is why, because half the sperm are Y and half the sperm are X, okay? And so under fertilization, you either get an X from the male or a Y from the male. Right? So that's how we get sex determination genetically from humans. Now, it doesn't work that way in all organisms. So we have X and Y for humans. However, it changes depending on the species. So I'm going to show you some different species and how their genders are, how their sexes are determined as far as genetics go. So in birds, it's the opposite from humans. So in humans, males determine the sex. In birds, females determine the sex. So in birds, males have 2 of the same sex chromosome, and in females have 2 different chromosomes. Now you'll see that we've named them differently, so that way we can differentiate. So X and Y for humans, W and Z for birds. So female birds are the ones that are going to determine the sex for their offspring. Now, it gets even weirder when we look at some other species. So the sex of the offspring in ants, bees, and wasps are not determined by things like X, Y, or WZ. They're determined by the number of chromosome sets for the sex chromosome. So is it haploid? So do they have just 1 set, or are they diploid for it? Do they have 2 sets? If they have 2, then they're going to be a female. If they have 1, they're going to be male. And the thing is if you're familiar with ants, bees, and wasps, a majority of the members of these species are going to actually be female, right? And when males are needed, they will produce haploid eggs that will hatch into males. But mainly they're going to make eggs that will hatch into diploid females. So kind of different in the sense that you don't have 2 sex chromosomes in order to determine the sex of the insect. Instead, it has to do with the number of chromosomes. Then in turtles, most of the turtles, their sex is not determined by a chromosome. Their sex is determined by the temperature that their eggs are incubated at. And so if the eggs are incubated at a higher temperature, they're going to hatch and be females. If the eggs are incubated at a lower temperature, the eggs will hatch and be males. And thing is that normally if you've got a turtle nest, so most turtle nests are going to be buried under the sand, and you're going to have a pile of eggs, right? And you would expect that, I know that's a great drawing of eggs, right? You would expect that the temperature should be pretty even insofar as you'd get a split of about half the eggs should be female because this top layer would be warmer, and half the eggs should be male because the bottom layer should be warmer or cooler. So that's how you end up with those guys. Okay. So then the question is, the sex ratio of number of females versus males of which species that I just talked about might be most affected by global warming or climate change? And the answer is turtles. Since their sex is determined by temperature, as temperatures rise, those nests, I'm not going to draw all the eggs, instead of the line being halfway through, the line now is down here somewhere. And so this is the only area of the nest that's probably cool enough, say, for the males. And so that is what we're seeing. We're seeing fewer males being born unless we bring the eggs in to hatch them at those varying temperatures to be able to get more males.